My name's Andreas Eichel from ProtoWerk4D. What is ProtoWerk? ProtoWerk actually is a prototyping specialist. We are focused on different kinds of processes to build prototypes for every kind of area, like chemical industry, bioindustry, automobile, Siemens, of course, but mainly in the small range. So you have a new idea and don't know where it leads to, then we will come up and will do the first step to it. The range is from small, simple things up to machines with robotics and automation. And within the last years, the topic of energy consumption of machines, of course, and the CO2 print of certain products has become more, more a topic to be watched, and therefore we took this into account and expand our experience in that area. For today, I want to talk about energy saving. We heard a lot about energy monitoring, and I found that most of our customers know that they have to do something, but they don't know how. And of course, like Luik already said, you have to measure it first, then you can improve it, and that is right. But when you measured it, how can you improve it, and what is the goal to it? So, an overview of the next of this presentation: what kind of energy to save, what kinds of cost will come up. Of course, if you want to save energy, want to implement something new, there's always one person that says, okay, what does it cost? Can we afford it? Of course, for the climate, for the earth, we have to afford it, but someone has to pay for it. How does energy and cost affect the efficiency? Yeah, for example, in production. And I will give some examples from industry, some practical challenges, and we will see. Okay, so there are different types of physical energy, of course, and energy sources. I've displayed here the most common. There are some more subcategories, I would say. But these are the ones you have to face the most. And in industry, the main topic will be chemical energy, electrical energy, of course, and thermal energy. Some of the problem is not always the usage of energy, but the loss. So if you use gas, for example, to generate heat or electricity, you will always have some losses, something you cannot use for yourself, or you have to transform into other forms of energy. And technically, you can transform every kind of energy to another. There are some restrictions, but for these 5 examples, it is possible. Sometimes the transformation is not the best way because the loss is really great, but technically it's possible. Here you will see some of the losses that goes hand by hand with transformation. I centered electrical energy because this is the one where you can easily transform into others with a minimum of loss. Of course, we have here, for example, the solar energy. That means the light in the room, for example. A few years ago, the loss or the transformation of electrical energy into light was only 5%. Now we are up to 40% thanks to LED. For other terms like mechanical energy, we have loss only on 10%. That's quite low. For thermal energy, even more, up to 98%. But the other way around, as you can see, to generate electricity from thermal energy is not always such a good idea. It's strong related to the Carnot process, and if you try to use, for example, thermal energy that you have available at your factory and want to transform it into electrical energy, often you don't have the temperature that is needed for a high conversion rate. So you have to take a look at every kind of transformation you do in your company, at your factory, if it's really necessary or affordable to do this. But it's not always necessary to transform energy. Sometimes it's better to use energy as it is and to store it, or even to actually use it. For example, when you use gas for heating and you need a lot of temperature, then you will always have a loss of lower temperatures that you cannot use directly. But if you have a melting process, for example, you can use overheating or the heat from the cooling process to heat up other areas, for example, heating buildings or warm water or something else. When you store energy, there are some pros and cons. For example, when you use heat sinks or cold sinks into in buildings, that is something that came up, I think 30 years ago, so it's already an old one. You have the problem that is really sluggish. So it's a long-term storage. A popular example for that is a building from an architect that was really into sustainability, and he put into the center of his house a large tank that will not only store heat, it will also store cold, so he can cool his house in the summer and heat his house in the winter. For that, you need a lot of space and a lot of time. To store electrical energy, of course, a battery is a good option. Fast available electricity. The change in putting in electricity and taking it out, the life cycle of the battery is sometimes not so ideal. We have this topic with electrical cars. You have to use them maybe every day. And the company says, okay, it will last for 300,000 kilometers, and maybe your car will only have 80,000 kilometers and the battery has to change. It's also a topic of how to use storage and if you use it the right way. To transfer the solar energy from PV systems to electrical energy is something that becomes more popular, even for personal housing. I've one myself at my house. Low costs, low operating costs. The installation, the investment is maybe a little bit higher, but on the long term, it could be a good investment. There's one thing you have to take into account. The more power you need and the more variation in power consumption you have, the more complex will be the solution. What does it mean? We come back to facility. Normally, you start the facility on Monday morning. In industry, it's 3-shift system, and you stop maybe on Friday afternoon. Then you will have different kinds of power consumption. For example, you turn on all machines on Monday, you will have a maximum peak on Monday, and then a continuous electrical consumption over the whole week until you shut down everything again for the weekend. This peak on Monday will cost you additional money. And to have something to reduce this peak, this can be very different. For example, process optimization, that you don't turn on every machine the same time, but in stacks. Or you have something to compensate these peaks, like a storage that can jump in and produce in this period of time for the Monday, for example, for a few hours, electrical energy, and to reduce this peak could be a good solution. And I hope I can display this a little bit better. If you use different kinds of energy, not only electrical energy, but also gas, you not only have to pay for your consumption, you also have to pay for the possible maximum you want to use, and this is related directly to the maximum peak of your consumption. Costs and efficiency. In my opinion, it goes hand in hand. So costs can be money, of course. CO2 in future will also cost. Contentment, acceptance, especially for big companies, it's more a value that it is accepted by the community, by the people, that they do something for the environment, for the climate. And that doesn't have to be lose from efficiency. You can save money, you can save CO2, and also be efficient in what you're doing. You just have to take a really, really close look, and you have to measure before you start to do something, what is the actually consumption or the actually costs, and where do I want to go? What do I want to achieve? So obviously, it's always good to not overpower in everything you do. When you overpower in your production processes, you will lose energy that will cost money. You can overpower in the work with your employees, with your people. Then it will also cost money because maybe they get sick or they get a burnout or something like that. And if you want to rise efficiency, it's not only the technical efficiency that you have to take into account. If you train your people, your employees, to work more concentrated, more with more thought to the end, to the product, and to the process itself, then they will work more efficiently. And with the example of turning on the machines on Monday, if they know that every machine will have a certain consumption in the turning on process, and they know that it costs additional money, if they are aware of that, they maybe think about not to turn on every machine at the same time, but to turn on one and make something else. For example, drink a coffee or something like that. And then go on over the time, work in the next employee for the next machine, or prepare the next machine for the next step. So well-trained and motivated employees can save energy and costs too for your company. I know sometimes it's hard to get this idea through the management. Maybe they have a hard grip on the money, but you have to display this in numbers. Then they will understand, and they will say, okay, if we can rise productivity up to 10%, and it will cost us a certain amount of money per year, it will be acceptable and maybe better than to do nothing. Here we have an industrial example from the past in respect to energy losses. They use gas and electrical power, gas for heating machines, and an example from what's the name? Lebensmittelindustrie, wer kann mir helfen? Food industry, thank you. It's an example from food industry. They have to heat their machines with gas and electrical power for compressed air, light, and moving parts. And you see here a lot of their gigawatt hours came from the gas. And in that case, they have also a lot of cost from the gas, of course. But also from the gas, they have the highest loss. The effectivity of the electrical power they use, if we don't take a look at the light, is really high, up to 90%. But for the gas, the heat is mainly going out in the environment because it's still hot, but not hot enough for the machines. So the typical reasons for up to 10% of losses in this company was delayed maintenance or not optimized heaters at their machines. Of course, old industrial lights, leakage at the compressed air system, and for the mechanical energy also delayed maintenance or even not realized defects. The argument of the management was we don't have the money for certain things to do. For example, we don't have enough money for maintenance. We don't have enough money to change the lights. And we say, okay, if you don't want to save money, you can do it as you do, and you have to pay the bill in a few years. Or you can now do something, you can save energy, you can save money, and will be at a good place into the next 3 or 4 years. And they were skeptic, of course, and we had to show them directly. What can we do in optimizing? We had to monitor the current status. That was this one without optimization. The productivity was up to 83%. 83% of the technical maximum at this moment, and the energy costs were we have set for this presentation on 100%. So this is our starting point. The target was to rise productivity and possibly not rise the energy costs, or just to rise the energy costs in respect to the productivity. Up to 85%, that is not up to 90%, that is not much, but for this company it was a big step. So what we first did was optimizing the current processes and the machines, doing the maintenance with the basics and with the basic costs they had. And what we see here is we already, by optimization, the actual processes, we already rise the productivity to this target of 90%, and we lowered the energy costs. Why? Because if you don't do maintenance, you have higher losses in the machines for moving parts, for heating energy that will not reach the correct place in the machine. And then we said, okay, we lowered energy costs, we rise productivity. What is now the theoretical maximum? And we found that the theoretical maximum will be even higher than that what they have calculated in the beginning. So what is the thing you have to take out of it? If you change something, you have to control your process. And if you change the process, you have to adapt the parameters. When you optimize your current processes, that means not only that you optimize the parameters or the process itself, you can also improve your process, and therefore optimizing the process can lead to a higher theoretical maximum. Okay, so how can we do this? How can we monitor our factory and therefore create an optimization process? First, you have to take a look at what goes in, the input in your company. Not only the energy, but also the products. We have heard here from other referees that you can also take the CO2 print of your partners that deliver you some resources, of course. And often you don't know what the circumstances of your partner is if you don't talk to him. For this industrial project, we took a look at the partners as well and at their processes, and found that it is easier for the partner to produce some products in a smaller package or in a larger package, and to give it to the actual company for a lower price in that case, as it was. So by talking with the partners, they optimize their logistics, and they lowered the prices of resources that they needed for the production. Okay, the next thing is you have to put everything that is in your factory into a black box. Black box, nothing else like something where you put everything in. You don't have to know exactly what it is, just name it. Maybe you can quantify it, even if it contains of different single parts, doesn't matter. Just name it put it in. If you can say, okay, it has this kind of amount on energy that is consuming, then you can place it there too. And you have to take a look at what's going out, the products, rest energies, losses, of course. And if you have the going in and going out, then you can calculate what's staying inside. And you can calculate out of it the CO2 print of your facility. At this stage, it sounds easy. We have heard how today that is much more complicated, but the basic idea is that. Okay, for this example, I displayed a few thoughts ago. It was 5 gigawatt hours of gas, 1 gigawatt hour of electrical power. The loss of heat, I already mentioned, was 3 gigawatt hours per year. The loss of energy conversion, 0.7 gigawatt hours. The management thought it was a good idea to transform some of the energy losses into other forms of energy. And yes, of course, you can do this, but that would have been a lot of investment, and I think the time the time of the return of the investment would have been 35 years or something like that, so really long. Our way was to say, okay, to convert the losses into energy we can use again, we want to reduce the use of energy. And there we have some challenges to face. For example, as I already said, the investment and the return on investment, the lifespan and the amortization period, practical use, risk in production. Risk in production is often a really, really sensitive point in the management. Availability of trained staff. If I don't have the people, I have to train them, of course. Future situation. We heard today that the CO2 print and energy losses and energy consumption and the impact on climate is something we have to monitor over the next years until 2050. So it's a long term and we don't know what the future will be there. What will be maybe additional costs? So how can we save the energy, and with this saved energy, save climate, and how to motivate everybody to go with us? You have to start with change you can easily implement. Of course, if there's a point you can do easily, you can do it. Why not? Focus on change with the best result. If you can change something, but at the end you will save only a small amount of energy, the return on investment is not so good. Don't do political discussions. This will always lead in to employees that will not go with you the way you want to go. And you need to get everybody on board. Challenge yourself. Yeah? Set goals and then go for it. If the goals are not reachable, then reset them. Reward success, of course. Everybody wants to be rewarded, if it's a word, a present, or something else. And be proud of what you have done. Okay. That's it. That's the old presentation. For this specific example of in industry. At the end, it was about $500,000 of investment they did. They had costs of over 40,000 euro per year on energy. Sounds not so much. They had a lot of energy loss, a lot of energy that was used just to cover delayed maintenance or machines that were already broken but still functional. And at the end, with our help, they could reduce the cost for energy down to 1,200 euro per year. They had an investment of 500,000 euro and an additional refund of additional energy they produce of 13,000 euro. So at the end, with a credit they had to use with all the costs and values they had from our modifications, they reduced their costs of from 42,000 euro per year to 37,000 euros per year. With a rise in productivity and reduction on energy usage. So this is from my side. I'm just in time. If there's any question,